right, everyone. Thanks for joining us for today's Git session. The main purpose of this session is not to teach you everything about Git. I'd like to get the essence. I'd like to have people mindset, understanding how Git is structured, what to expect when we work with Git, and not to give you all the cheat sheet for all the commands. You can, of course, Google them later, but you'll be able to implement them because you know what Git expects from you and how to interact with it. So that's the purpose of today's session. The purpose of Git, let's start by we have markers. I'll grab some. The purpose of Git is really to help you protect yourselves and others from yourselves and others while running code, while writing code. Really, when you work with Git, you work on your code and you can know that you can't mess up things too badly because you made save points, you made checkpoints. And the idea of checkpoints is familiar to everyone who ever played a video game, right? So you have your character or whatever you're playing and you make your checkpoints, save points, that you can always go back to if you get to a dead end in the game, if your character dies or anything happens. If you remembered to make these checkpoints, you can always go back and continue playing. Too bad we don't have that in real life, right? But we do have it in Git, so that's great. So we'll use that to go back if something went wrong and also to document our workflow of writing computer software correctly. Let's take a very simple example that I think can relate to just anyone here. Let's say you're working on a paper. So you make a Word document and you name it. If I write here, Max, on the board, will the camera see? Here?
Yeah.
That's okay?
Yeah, that's fine.
Right. So that doesn't leave much space. So if your document is called...
You can go further left.
Yeah, so is that okay?
Yeah, that like...
Is that okay?
Right. Yes.
Yeah, the second one? Alright. So I'll use that. So if your document is called, let's say, paper dot docx, right? And then you make a different version of it and you'd like to keep the versions because you want to go back. If you deleted a paragraph, it's always there. So next thing, you'll call the next version paper2, right? Docx. And then you give it to someone to review. So let's say you just gave it to Smith. So he'll return paper2 underscore Smith Johnson dot docx, right? Then you get it back and you have a new version. Then you have, and you understand what's going on, right? And you have a final version, docx. And if that's your final version, you might want to send it to your boss, so your boss will return the paper, and that will be paper blah 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 underscore final and your boss's name dot docx, and then you make some changes and so on and so forth, and then it will be new, and then it will be final, new, and very new, and the recent new version, and then yet another one. So that's not a really good way to work with documents, and we all should have a better method to do that. But when it comes to code, it can be even more complicated because you have different people working in parallel on the same piece of code. And Git is really here to help us to write code in an organized way. So I really love Git. I really love how it helps us, helps the workflow of writing code, but it wasn't always the case. At first I was very frustrated when I started working with Git, and I think by the end of this session, if you can just understand, and hopefully the session will help you understand how to think when you work with Git, and not to be frustrated when you see a new Git command, or when you just Google it and do whatever you want with that workflow. So let's start. First thing, let's make sure you all have git installed. So what you'll do in Linux to get git is typing sudo apt install git-all. That's how we install git on Linux. To make sure you have git, if you already installed it or if you don't know, type git space dash dash version. On Mac, you'll just type git dash dash version. If you don't have it, it will prompt you to download and install it. So go ahead, make sure you have git. If not, then install git. Yes, please.
Really old. Would now be a good time to update before we proceed?
You can go ahead and update. Yeah, we'll wait for everyone to install. It's not crucial though that you'll update Git. It's great for your workflow. For this workshop, we'll do just the basics. You don't have to.
On that note, if you install Git through apt makes sure that the packages are up to date every now and then, as long as you update your OS software. Sometimes you'll get pop-ups on Ubuntu about that. As long as you've been doing that regularly, then Git is up to date. If not, there's the commands sudo apt-get update and sudo apt-get upgrade as well. So Git should be up to date. So
All right, if you do that, thanks. Thanks for the comment. So if you install Git through apt, as Mark said, the system will keep it up to date for us. Is there anyone here which doesn't have Git or is installing Git? Or can we proceed? All right, let's proceed. If you haven't used Git, if you're just using Git for the first time right now, there are just some definitions we'll have to go through, defining your username, email address, right? That we'll do right now. So let's do it together if you haven't already. If you already use Git on your computer, it should also already be configured. To check whether you need to configure it or not, type git config --list. Here it tells me, I know you, here's your email and your username. If you don't have that set up, you simply type git config //global. So everything you do now will take effect in all your Git repository. We'll define repository soon. Next you type user.name, the actual words user.name, don't replace it with your username. Then in quotation marks, your actual username. So I'll do Alon GD. So press enter and you just updated your username. Git also needs to know your email address. So same thing, git config --global user.email and give it your email address. Press enter and you just defined your email address as well. To check, type git config .list, git config --list, and it should tell you your username and email that were successfully configured. All right. Assuming everyone already has their Git configured, what I want to do is, in this session, it will be an interactive session. We'll end up with an exercise, but really the entire session is everything we'll do together. So try to keep track of what I'm doing here. Let me know if I'm doing it too fast or too slow, and let's do everything together. So just open our folder. Here's my home directory. In it I have my code folder where I just put my repositories. So programs I work with, you can see RMG and RMG database. And let's open a new folder. It could be here or wherever you want on your computer, and call it Git exercise. So here's the folder, entirely empty, right? We just created it. Let's cd into that folder. Let's change a directory into the folder we just created. So I will go ahead and cd into code and then git exercise. If I type ls, as Mark showed us, I see that the folder is empty. the next thing you want to tell Git is to keep track of that folder. Let's say that will be my new software. I'm going to put all the code right here inside Git exercise. I'm going to make that my repository. My repository will be where the software is located, where the software is saved. So to initialize a repository, we'll type git init, which is short for git initialize. You just type git init. You don't give it any other name because the folder's name is already what we'll refer to as the repository. I'm typing git init, and it told me I just initialized an empty git repository inside that folder. If I go to the folder and I want to see hidden files, I'll see there's a hidden directory. It starts with a dot. Remember, these are hidden files or directory. There's a hidden directory here called .git. I'll go ahead and hide it again. You don't need to look into it, but just know that that's how Git will process or will think about files in your directory behind the scenes. So if you did that, you already have a new directory, a Git exercise, and it's also a Git repository. So Git knows to keep track of everything that goes on inside that folder. Let's go ahead and create a new file inside that folder and see how we keep track of it. So a new document, empty document, and let's give it a name, meow.py. So here's our software. It will deal with animals, and here we'll do something with cats. Go ahead and open that file. So we have meow.py. I'll open it with my text editor. And let's type something. It doesn't really matter what you type. Let's try to do it together. So whatever I do here, you can also exercise on your computer. Let's say it's a Python function. So I'll type def change cat color. So that will be a function for changing the color of my cat. It gets an argument, a parameter, color. And since we like green cats, let's say if so it gets a cat and a color and a new color we want to change into, and let's say if cat dot color is not equal to green, let's change. So cat dot color will be equal to whatever the user just gave us. So if it wasn't green, we'll put the new color in. If it was already green, we'll preserve that color. That's what the function does, and we can return the cat object. Save that file. So you can see here currently it's red, so I'll click Control S. If you have a different text editor, Nano, or just Notepad, whatever you want to use, just save that file, and you have a saved file inside your folder, meow.py. We can also look at it. We just said that cat, right? When we're dealing with cats, and we just saw the command cat and explained it in the previous session. If you do cat meow.py, it will throw the content of that file into your terminal. So here it is. We won't execute it. Don't worry, we're not doing anything with Python in this session. If you have a typo, if you did anything different, no worries. It's just an example. So how does Git think about our files in the new repository? What's going on? We can describe the current files and folders within a repository just the way you're used to, and we'll call it our workflow. And our file meow.py is here, right? So what's a workflow? Nothing but what you already know about files and folders. Nothing special. We said that Git is all about creating checkpoints, save points that we can return to later, or that we write code in an organized way in a group that people can keep track of exactly what we did. So let's keep track of the change we did. We added a new file and we'd like to tell Git to keep track of it. What we will do is we will stage that file. We will add that file to the stage. So here we have a new territory of how Git thinks about stuff. We said we have the workflow, which is just what you already know about files. Then we have the staging area, so or the stage. Before we make a checkpoint, we'd like to tell Git what's the package of files and folders, but not only, also changes within a file. I can change one line in a file and tell it, keep track of that. That's my current package. I'd like to stage it and make it my checkpoint. I'd like to think about it like playing golf. You first put your ball on the cone. How is it called? Just a cone in golf? Sorry? The tee. All right. So you take your ball, you put it on the tee. So you just staged it. If you're going to hit it, wherever you're gonna hit it, what's gonna fly now is everything you put inside that ball. So that's staging. You can take several files. You can also take minor changes within files, package them together, and stage them. So think about that as your ball on the tee. You haven't created a checkpoint yet. You haven't committed to strike it, right? To hit it. You just prepare the stage. And that's what we're going to do next with our meow.py. We're going to add it to the stage. Don't expect anything to really happen with the file. The file will still be here. It's the same folder. We'll have a meow.py. You look at it, nothing is changed. But just the way Git thinks about it. When we will tell Git to hit that ball, it will know exactly what to hit. There's one file here that we care about. Let's do that. The first command that we care about that will help us understand what's going on is git status. So let's all type just git. Everything will start with git space something. So let's type git status and see what will happen. So Git tells us, on branch master, don't worry about branches right now, we'll talk about it in the next hour. On branch master, untracked files, and here it is in red, maybe hard to see, meow.py, and nothing else to report. That's my file. There's an untracked file, so it's not staged, not committed, it's just a file. We said the command was git log, and with your permission, I'd like to write here all the important commands that will just help us figure out what just happened. And all the commands I'm going to list here are harmless commands. You can always just type them to make sure to check what happened. They will not perform any real action. So, So commands to check what just happens, all of them will be harmless, and I'll say that over and over again today. Use these commands a lot to visualize, to understand what's the current situation, how Git currently thinks about your files. So the first command might be what we just said, git status. Git status relates to the way Git thinks about files. The workflow, just normal files, or the stage, files we just packed together and are telling Git they're ready to be hit in our golf analogy. So let's do that. Let's add meow.py to the stage. How do we add a file to the stage? Very easy. We just tell Git to do that. Git add and autocomplete tab for autocomplete. That's the only file there. So I'm adding meow.py to my stage. Let's hit enter. Nothing happens. It doesn't say anything. I'm looking at the file in the folder. Nothing changed. I can open that file. Let's do that. So it was previously opened. Let's just reopen the file. Nothing that surprises me. Nothing happened. But something did. We can't see anything that really happened here, but the way Git thinks about the file just changed. Meow.py it no longer lives here in our workflow. It was just staged. Again, we don't see any change. The file is still in the folder. So what really happened? Let's type our command that will help us understand what just happened, which is harmless. What was that command? It's git status, right? So type in the terminal git status. Something's different. Before, look at the red, right? Before, when we typed git status, it told us there's an untracked file, meow.py. I can see it, but I'm not tracking it. I don't care about it. Git says I don't care about that file and I'm not tracking it. But now Git tells us there are changes that could be committed. We'll talk about commits soon. And there's one new file. I'm totally aware of that and I'm tracking that file. So nothing changed, but just the way Git thinks about that file just changed. Git is aware that there is a new file. Let's remain a little bit, let's play a little bit more with the staging, with the git add command. I'd like you to all open again meow.py and let's change something. What can we change? We can add a new line after we change the cat's color and print changed cat color, or successfully changed the cat color, whatever, right? If I'm not saving, nothing will happen, so let's save, Control S, I just saved that. So I made a change in a file that was already staged. What's going on here? We said we had a file in the workflow. What's the workflow? Normal files and folders, the way you knew them before Git. We had a file there. We just added that file to our stage. Once we hit the ball, the file will be there. But now we made something different. We changed something in the file, and I'm a bit confused. Can you help me figure out what just happened? Or how can I figure out what just happened? What shall I type? If you won't answer, the session won't end. So what just happened? How can I figure out what just happened? What shall I type? Git status, right? Well, that's the only command we currently know about to help us understand what just happened. I'm typing it again after the change. Right? We just typed it together after we added, after we staged the file. Great, and we saw that Git knows about it, but now it tells me there are changes to be committed, and here's the green meow.py. I know about that file, but wait, there's something else. That file was modified. I'll scroll up and you'll see before I had a red file, Git didn't track. Now I have a file that Git tracks, and it knows the file was modified. What exactly got modified in that file? Maybe it's a 2,000 line Python code and something got changed there. I want to understand, because if I'm to stage it, if I'm going to put it in the golf ball and strike it, I want to know exactly what I'm putting there. That's the way I make checkpoints, right? Save points, and I just lost the word, sorry. So, right, checkpoints, that's right in the video games. So that's how I make these checkpoints, or that's how I report to my colleagues how my code is arranged. So the next command to understand what just happened, what's the difference between the current version that Git knows about and something that changed, is called git diff. Let's type git diff. And look at that, isn't that cool? Here's a portion of the file. Actually, it looks like it's the entire file, but if it's a 2,000 line file, it won't show you everything. That's just the portion that you care about. And in green, and there's a plus sign here, it tells us what got added. If something got deleted, it will have, and actually we can do that soon, it will have a red line and with a minus sign telling us that something just got deleted. We have a modified file, so something can be added and something can get deleted. So, yes?
If you had many files that got updated, would it show them all?
Yes, yes. So git diff will show all the files that got updated and where they got updated. And if I didn't stage a lot, if I just wrote lots of code, that will be too much to scroll. That's right. Yes.
So is there a more specific way, like git diff just meow or something, just to
Yes.
do that one?
Exactly. Git diff and file name will just diff the file.
Yes, yes. So I'll repeat that for the recording. If you care about just a certain file to see the difference in it, you can do git diff space file name. So it will give you the difference just in that file, not all the files that just got changed that are being that we're keeping track of. All right. So I'll add that to our list of commands, which are harmless and help us figure out what just happened. So next bullet point here. Git diff. Git diff or git diff space certain file name will help us figure out what just changed in a certain file. So when we're going to hit that ball, we would like the latest change that we just remembered to add to our code to be included in that golf ball again. Or if I lose the analogy, we would like the entire meow.py file to be staged. The current situation is that in our workflow, we have that file meow.py with just one, let's write one addition, one line got added. And what's staged is all the content of that file but one line. So meow.py missing a line. I take the time to explain it again because I don't want us to think about the workflow or the stage as the entire file being moved around. First, nothing gets moved, right? You saw that the file remains in the folder physically. Sorry, here's the folder. Physically, nothing changes. But also the way Git thinks about our code, Git doesn't think about entire files. It might if that's everything that just got changed, but also if you change a line, so one line can remain in the workflow, it's not staged. Everything else, for example, what we did is staged. So let's add our one missing line that we forgot and just add it. So going back to the terminal, to add something, what do I type? To stage something, what shall I type? Git add, right? Right. Git add meow.py. Great. Git doesn't tell me anything. If you all type git add meow.py, I don't get any feedback. How do I know what just happened? Git status. Sorry for asking it 1,000 times. I'm going to ask it 1,000 more, all right? And really, Git could be frustrating, could be hard to understand if we're not using these tools. If we are, then we know what just happened. All right, so we know what to do next. Let's do Git status. Great. Before, when we did the status, I'm going to scroll up, take a look. Before, we had a file that Git is aware of, and there are changes to be committed. That's what it says here, changes to be committed. So that's staged. It's a file in our stage. But the file was also modified. So there's a line there. We know it's a line, but even if it's 200 lines, it will say it's the same thing. Something got modified, it's not staged. Just for you to know. Now when we type git status, it tells us there's one file and it's all staged. There aren't any changes I'm not keeping track of. Yes?
So what happened to the previous version?
Excellent question. What happened to the previous version? We said that Git helps us make checkpoints, like a video game. But we haven't made one yet. So we code our way in our software, but if we're not making checkpoints and we haven't seen how to make one, so nothing. So there is no previous version. If we really want to, you can go to the text editor, hit Control-Z, and see the previous version. But Git won't return us there because for Git we haven't defined our ball and striped it yet. So there's no version yet. Excellent question.
So just as programming practice, how often do you keep
Yes.
this saved?
So practically, when do you commit? There are different ways to think about it, right? Different ways people implement it. One way would be to just write a simple function and commit it, right? Or you can write several changes in different files that are all related to each other and commit that. You should do it quite often. But then what happens if you go back to a function that you wrote at the beginning and you'd like to change it a little bit? So there's a way to incorporate these changes inside the first golf ball, but we'll talk about that later, and we won't even practice it in today's session. So there are lots of Git commits. As I said, the goal for today's session is to have a good set of mind of how Git thinks about files, how they are being, how Git thinks about the workflow. We won't cover everything. Yes.
So there's no protection. If I type git add and name the function, it happens to be the same function I already have. I'll just overwrite the old one. Unless I committed it.
Yes. We haven't committed anything yet, and unless you commit, right, there's no protection. That's correct. All right. I'll take a all right. Okay. So let's do that. Let's create a checkpoint. Before we create a checkpoint, I'm just curious, what happens if now we do the second command, which is harmless, just to see what's going on, git diff. Previously, git diff told us there's one line which got changed. We just staged it, right? We just added it, so we just staged it, and we see the status. So what we did here, visually, the entire meow.py file is now staged. That's our current state here on the computer and here on the board. If we do git diff, what shall it tell me? That nothing is different in my repository, right? Everything is staged. There's nothing that just got changed that Git isn't keeping track of. Git is keeping track of everything. the next thing we would like to do is tell Git to wrap up all our changes that we care about and that are related to each other. In our analogy, that's the ball that we care about, and save all these changes with a meaningful and nice title. And that's one change we make to the software. Let's repeat that. So you made a new file, you can make several, you just made some modifications to several files. You'd like to tell Git to wrap up all these modifications together. So we're adding them to the stage, we're staging all these modifications, and we're going to save them together and give them a nice title. So everyone who looks at it will know exactly what that package contains. And we call these packages commits. So you made some changes in your workflow, you stage them, which is in our analogy is our golf ball. Am I missing a marker? I wish I had Git to keep track, thanks, of, yes, thanks, to keep track of the markers as well, not only the code. And the next thing that will, and the final thing, the third thing that we need to understand when we speak about Git is commit. So in our analogy, we're preparing all our files into the nice golf ball on the tee. And when we commit, we'll strike it, right? And then we'll send it to Git's history, and it will remember all of that for us. So to save that checkpoint, we'll type git commit -m for message. We'll give it a message, and we'll tell it in quotation marks added meow.py and quotation marks. That's how we tell Git to actually make a save point for us. If anything changes, we can always go back to that particular version. Let's hit enter, and it tells us it created, there's one file change, 5 lines of insertions in that file, and it created some mode, gives us a number, we'll talk about that later, and here's the file that got changed, there's a commit here. Still, I'm not that satisfied. I want to understand, I want to visualize, I want to see what just happened. And we have another command to help us understand what just happened after we committed. If you want to see a log of all the changes, all the commits in your repository, all you need to type is git log. We just committed a change, let's type git log to see it. Here's the history of my entire repository. There's just one thing that happened here. So git log only keeps tracks of our commits. There's one thing that happened here. You can see the author. Before we started, Git asked you for your username and your email address. So here's who did that, when, and our helpful and friendly commit message, which is very important. Don't just give a short commit message that isn't helpful for others or for you to later figure out what that commit contains. Give something really descriptive, it's important. If I'd like to visualize what just happened here on the board in our analogy, meow.py is no longer here, it's no longer in the stage. We just committed, we just striked or hit the ball, so our file is here. It's committed. Or more correctly, the changes we make to that file. because we can make more changes to meowpy and commit them maybe separately. You know what? Let's do that. Let's reopen the file and change it. What can we do now? Let's make a new function. Def get cat name. And the argument here is cat. And you can type if cat dot name is not none. Again, the syntax doesn't really matter, we're not going to execute it. Print cat dot name. Else print cat has no name. And let's save it. I added a new function. We really don't care about the content, but let's just add something so we're on the same page. We added a change to that file, a new function called getCatName. It's getting an argument, a cat object, and if it has a name, it will print it, else it will tell us there's no name to the cat. All right, so if you all did that, let's go to our terminal. The next thing I'd like to understand is what just happened. Out of the commands we typed, which one is the one which is relevant to our current situation that a new file got modified? A file got modified.
Status.
Git status, that's right. Let's see the status of our repository. Git status. Git status will tell us how Git currently thinks about the files. What just happened in the regarding the workflow stage and commit way of Git thinking about our files. And the file still remains in the same folder and nothing has changed. So typing git status, we can see there's a modified file. Git will not report any files which were already committed. We'll see it soon. It will just report on changes. So there's one file, it got modified. All right, what got modified in that file? What shall I type? Git diff, right? Git diff. And you can also practice, give it a file name. Here we just have one file. It will be the same if you give it a name or not. So git diff meow.py will tell us exactly what happened. So here are several lines which got added. Some blank lines and the function we added. These are the changes. If I type git log, what shall I expect to see? Our third command of figuring out what just happened. So git log will tell us what are our commits, or what is the commit history, what are our save points. We did not make a new save point, right? So if I type git log, I expect to, right, just see the previous one, and the new changes we just added aren't saved, aren't committed. So let's do that. If I have a new change to meow.py, what's my way to getting that change into Git's history of checkpoints? What's the first thing I need to do? Before I commit, what's the first thing I need to do if you look at how Git thinks? Just say it.
You gotta stage it.
Correct, correct. The first thing you need to do is to stage it. Let's do it more interesting. So, of course, we can now stage the change that we just did. We practiced it, so I think you got the hang of it, right? We're going to stage that change. Great. Then, once we stage it, we'll commit it, and we'll give it a commit message. Wonderful. Before we do that, let's make things a bit more interesting. So, let's go back to our folder and add a new file. We'll call it catName.py. We just added a catName function to meow.py. Here it is in git diff, you can see it. You know what? I changed my mind. Let's rename that file. Instead of catName, let's rename it to catnames.txt. Let's not make it a Python file. It really doesn't matter for the exercise, but let's make it a little bit realistic. And I don't want to write any Python function here. I want to just give it some cat names. That's it. So when we execute the function, it could allegedly access that file through some other functions and read some cat names. That's it. Where am I going with it? I want to add a new file which is related to the change I did in some other file. So later, when we tell Git to make a checkpoint, a save point, we'll tell it that the package that we care about currently consists of a new file and a modification to an already existing file. That will be our package. That is what we will stage, and we will commit them all together, because commits are chunks of code that is related to each other and that we care about and that we would like to make a checkpoint together. So let's do that. Cat names. We have Eduardo, we have Lily, and we have Joseph. Whatever you want. So here are some cat names. Let's go back to Git. I want to understand what just happened. So I'll type git status and look at that. First, we have a modified file. We still haven't staged, haven't committed, we haven't done anything to our original file. We just added a function to it, so we modified it, and Git tells us, hey, there's a modified file. Other than that, look, there's a new file right here that as Git, I'm totally not aware of. It's a new file. Git is not keeping track of that new file, catname.txt. We would like eventually to make a save point of all these changes together. And as you correctly said, the first thing to do is to stage it. To stage it, the command in Git, or maybe let's write it here. To stage, in order to stage, you type git add. That's how we stage. We add things to our package, to the ball, or whatever. In order to commit, I'll just repeat the command we just saw. We type git commit -m and some very useful commit message. Don't forget that, otherwise no one will know what's in that commit. Almost. So now we need to stage two things, and we have two ways to do that. If I want to, if I have many changes, and out of them I'd like to stage only these two changes out of many, I would say git add meow.py. I'll stage the change I did to that file. I won't do that right now. I want to show it the other way. And I'll also say git add catname.txt. So I'm packaging both of them together. There's another way to do it. You can do git add period, git add dot. It will stage all the changes in my repository all together. If you have several files, lots of files, you don't want to type each one of them. So git add period will stage, will add all the files, and will tell Git to keep track of them. I want them there inside my package, which will eventually be turned into a next checkpoint. So git add period, no feedback, Git doesn't tell me anything, and I want to see what just happened. I'll type again git status. Now it's in green. Now it tells me there's a new file that Git hasn't touched before, catname.txt, and there's a modified file. Meow, we were aware of it, we already committed something for that file, I'm keeping track of it, but it was just modified. Let's visualize here on the board what just happened. We made some changes to meow.py and we added cat name txt. Then what we just did when we typed git add period, we staged all of these changes together. So we moved all that, let's call it block A, we relocated it here. So it's no longer in our workflow. Again, nothing happened in my directory. I still have two files. When I staged them, when I told Git to add them to the stage, nothing happened to the file. Just the way Git thinks about them has changed. So they're both staged. They're both right here. Package number A. Package A. Next thing you'd like to do is to make a checkpoint. And what's the command to actually do that? So the command to commit, git commit, right? Git commit -m and a useful and meaningful commit message. So git commit -m.
What happens if you don't give it -m?
Good question. What happens if you don't give it -m? Don't try it. Don't. If you don't, yeah. So if you don't give it a -m, it will open up a text editor, your default text editor, and will ask you to give the commit message there. Thanks for the question. Currently for the exercise, we'll do it with git commit -m as if it's just one commit inseparable. So let's give it a useful commit message. Added, I can scroll up and see exactly what I added. Get cat name to meow, and added some cat names. Right? We added a new file and we modified meow.py. So we say exactly what are the changes we did, or what the changes we did are. Hit enter, great. We created a new commit, and here it is. Here's the commit message. The commit gets a nice, or we have our mode, I think, no, yeah, all right. It's not the commit number, that's the commit number right here. We have two files which were changed. It tells us how many insertions we have, and there's a new file name, a new file we added, and Git's aware of that. What's the command for me to find out what just happened in terms of the history of the commits? What shall I type next? Git log, that's right. So git log will tell me what are all my checkpoints that the repository has. And it has two checkpoints, right? The first one, added meow.py, it's at the bottom. Then the most recent one, and you can see dates and everything, the one we just did. So, yes?
To do all of these vector commits, you don't use the GUI? Okay.
Sorry, come again?
You never use the GUI?
Oh, okay, excellent question. Do I never use the GUI? I always use the GUI.
Okay.
So the purpose of today's session is to see how Git thinks. And it's also important to master the terminal commands of Git. And I cannot emphasize that enough. Yes, there are plenty of GUIs, graphical user interface, where you don't have to type, you just click stuff, then give a commit message, and it gets it done. Very useful. Please consider using it later on. But just for now, if you're a beginner, if you haven't touched Git yet, it's very important, I think, to have some experience working with Git in the terminal, actually in your actual project. The terminal is very powerful. You can do everything there. Then the GUIs are great. They're very helpful. They'll save you lots of time, but sometimes they have glitches or not all the commands, or you can't find something, or you just want to see what just happened. It's very important you'll have the security to go to the terminal and see what happened, or maybe make one command if you need it from the terminal, then go back to your GUI. So if we'll have time, I'll talk about GUIs at the end, right? So yes, we do use GUIs, but for now it's important to see the commands. Thanks for the question. So I think that's a great point to see if there are any additional questions about what we did. I'll give a quick summary and I'd love to address any questions. What have we done so far? We said Git is a way to protect yourself and others from yourself and others when you develop code. Really, Git is a version control tool. It's very hard to explain what a version control tool is unless you've seen a version control tool, but you just did. You can see different versions of my repository. What is a repository? It's just a folder that Git is aware of. How did we tell Git to become aware of my Git exercise folder? We did that by initializing Git in that folder. We typed Git space init in the beginning. We initialized Git. So Git is aware and keeps track of everything that happens in that folder. And the most important thing that you can get out of today's session is how Git thinks of my files. Nothing changes. Yes?
Git log, I expected to see the previous version that you had posted earlier.
Right.
How come it only shows the latest one?
It shows both. So when we type the Git log, at the bottom we see the first commit. So here's the commit number.
Oh, I see. So it starts with
Yeah,
the most recent
yeah,
one.
at the bottom, and the most recent one is at the top. And that's the recent changes we did. Recent changes.
Scroll down through 8,000.
And you can scroll down in RMG, right, 8,000 commits, that's right.
Okay, and this might be where graphical interface could really help with this.
Sorry?
Yes.
The graphical interface could show better than just having it.
Yes, yes. Excellent comment. The graphical interface can show us what happened. Let's do it in a minute or two. Let's see, not using a GUI exactly, but let's see a different way to visualize commits. Before we do that, I just want to finish my thought from before. Summing up the first section of our session, the way Git thinks about our files, we have the workflow where that's what you did so far before you worked with Git. All your files and folders are in your workflow. Whatever we want to package together and save as a checkpoint, we'll add to our stage, and you can add as many files as you want, and parts of files and deletions, whatever you want, all changes. Once you added them, you can commit them, and you make a commit, you give it a commit name, it gets a complicated commit number, a unique one, and you can always go back to that. So with that, I'd like to address any questions that that you have so far before we advance, so let me know. Yes, please.
So the checkpoints are,
Yes.
history of those are being saved elsewhere, right? Is it, or I guess, is it being saved with us? Is it being saved on some cloud server?
Good question.
Like GitHub?
Yes.
Where's it being saved?
We still haven't seen how to integrate it with the cloud, with GitHub. We still haven't done that. So everything we did, and it's an excellent question, everything we did was just made locally on our computer. So we do see here just some text, right? Just the message we gave it, and it got a number. But really, what that represents is change to our code. So if I were to revert that commit, we won't see it right now, but if I were to tell Git, hey, wait, I committed something, I wasn't sure about that, I want to regret, that's the beauty of Git, we can do that. I can tell it, here's the commit number. I don't have to give it the entire number. It's enough to just give the first 6 digits or so, and I can tell it to revert it. And that depends on exactly what I do. We will see it later. That these actual changes that I did will be gone. All right. So using that, we can actually modify the files, go back in time, go back through the history, and it's saved, as I showed you, in the hidden Git folder here, under Git exercise. So to sum up the answer to the question, everything we did was done locally, and these actually represent changes to our files and folders. Git knows what to relate, what changes to relate to each of these commits. Any other questions? All right. So, as Bill mentioned, I think it's reasonable at this point to just visualize how commit looks and what they actually are. I'm not screencasting that, so let's see if you can point the camera at the screen instead of me. So we'll capture that here. I just went to GitHub to the RMGPy repository. Again, the name repository. A repository is a folder, a project, a software. I can have it locally, I can have it online as well, the same software. As you did in the previous session before with Mark, you installed RMG, so you cloned an online repository to your computer. It is still the same repository. We can make different changes, we can diverge, we'll talk about that later. I can see in RMGPy, under the code tab, we're currently here, I can see we have almost 9,000 commits. Today, together, we did 2 dummy commits, right? Now we have 9,000 commits in RMGPy. I'm clicking that, and I can see, just like we did in our terminal, a meaningful commit message, and the commit also has the commit number. It's longer than that. Here it just shows the first 7 characters. The meaningful commit message could be as long as you want. Exactly what happened here. So the commit here says I updated a specific file to include something after, and I added a try except block, and exactly what happened here. So if I want, just from reading the message, I can understand what happened, but also I can visualize the changes which relate to your question from before, Chas. So what exactly is included in that commit? Let's open that commit. I just clicked it and I can see, really, someone said they changed utilities.py, and the file that got changed is utilities.py, and they did add a try except block, and exactly as they said, I can really see what got changed in the code by looking at the commits. I can leave my message if I'd like to ask a question. So just briefly, we visualize the commit. We can see a more complicated commit maybe that contains several files. Here's a that's a pull request. Max, can you help me identify quickly a commit that might involve several files in it? Unit test? No. Here it is. Oh no, that's one file. That one? All right. So we changed some import try except blocks, and here's one file that got changed. We removed a try except block and just added a different line. We won't discuss the content right now. Here's a different file with a similar change. You see all these changes which are similar got wrapped together into one commit, which makes sense to wrap them together. So this is how we can visualize one way. We can visualize a commit. We can also do that with local GUI tools, not only online with GitHub.
actually the person who, like it is possible for me to actually pretend to be, I don't know, Max and make a commit and push it to our repository. And unless we do some crypto stuff that we really don't need to do, there's no way of confirming that I am who I say I am.
Right. Our next topic relates to more practical things. When you develop a software together with collaborators, when with colleagues, each one might want to add different features to the software. How would that go about practically? We just saw that a software consists, at least the way Git thinks about it, as a list of commits. 9,000 commits for RMG, 2 commits for our repository, our demo repository. So here it is, just a random number of commits. C1, commit 1, commit 2, commit 3. Each commit has a meaningful commit message. Each commit has a unique name. You saw the, I don't know how many characters it has, which makes it unique. And each commit stores information that tells Git what exactly got changed, in what files, which lines, what got added, what got deleted, and so on. So here's my software. The way to think about collaborating on a software is to think about it as a tree that has branches. And so it all starts with the trunk of the tree, which is the current state of our code. Let's say we have these random 3 commits. And then Max says, I'd like to add some aromatic features to RMG, so it will handle aromatic species better. So Max clones, just like you did, RMG Pi to his local computer. Of course, we do it only once, and you keep it up to date. Once he did that, he'll create a branch. So he has all these commits. He doesn't want to miss anything in the up-to-date state of RMG, which has here 3 commits. He branches off to a different branch, and he calls that branch aromatic features, and he adds some commits. So CA1, the commit for the aromatic branch, of course the name doesn't mean anything, it's just for us to understand. So CA1, CA2, and CA3, Max just added 3 commits to his branch and unit tests and everything, and he's satisfied with that state. Simultaneously, someone else wanted to add a different feature to RMG. So they'll add that different feature. They are unaware of what Max did. Or you can say, maybe they are aware because they collaborate, but they want to wait until Max has finished to do everything. So let's say Mark just wanted to add isodesic reactions support to RMG. So he'll branch off of the current most updated state. He's unaware of what Max did. And here's his branch. It will have commit CI1, CI2, CI3, and CI4. Right? So far makes sense. Then Mark was very quick. He wrote that code, added unit tests, tested the entire thing, and asked for a review. Everything's great. And now we would like actual RMG users to enjoy that feature. So we will merge it to the RMG tree. So the current state of RMG, the updated version, will include that branch as well. And that might be easy, right? We'll remove these commits from being part of our branch, and we'll say, here's the updated version of RMG. Let's continue it with some more commits. So we had CI1, CI2, CI3, and CI4, and users that will now clone the RMG repository, or already cloned but will now update RMG, will enjoy these features as well. Beautiful. But now we have a problem. Max added the aromatic stuff. He wasn't that aware of what Mark did, the isodesmic stuff, and his commits or his state of RNG is only aware of a certain part of the code, of only a certain extent of the commits in RNG, just because they did it at the same time. So I plotted some tree here and some lines that represent commit, but what will Max actually see on his laptop? So he sits here, right? If he types git log, he'll see a chain of commits, the most recent one at the top, that say CA3 is the recent one, CA2, CA1, C3, C2, C1. That's the log, that's what Max will see when he types git log, right? His commits. Now we would like everyone, all RNG's users, to enjoy the new features of better aromatic handling in RNG. So we'd like that to be merged as well. To do that, we'll have to take Max's code and put it where? How do we add it to the current state? We can't merge it, we haven't discussed all these things, I know, but if you're building, I have a kid, a 3-year-old kid, and she likes to play with blocks, right? So if you build a block tower, right, and someone else came and added some blocks, and you want to add your blocks as well, you will put them at the top, right? Right? So there's some history to our software. We're not really changing the history of the official version, or we're not changing the history of the official version. We can do some tricks on our local branch, on our local repository, but to add new codes, to add new blocks to that tower where someone else came and added a few blocks, you'll do it at the top. You'll build more stories. So what will we do with Max's code for aromatics?
Add it to the top.
Right, add it to the top. Let's do it. So once the unit passed, the tests passed, and once it got reviewed, only then we'll add it to the top and we'll merge it into the official version of RMG. Now a user that clones RMG, that updates RMG, will get to enjoy all these features. And you can imagine the actual situation. So many developers, so many things going on, and each developer works on different features. They all branch off to different branches. And that's our next topic, branches in Git. I'd like you to go ahead and just type git branch. It tells you there's one branch, it's called master. It's green, so that's the current one, and it's marked with an asterisk. So 2 ways to mark and tell you that that's the branch you're currently on and there are no other branches. What's that name master? It's just a default name that Git gave, the current and only default branch we have. And the way to think about it, the master branch should be the clean version of your code, or the code that you'd like to present to others, or the version of your repository that your boss really cares about. That's master. Then you make different branches and you experiment and you add features if you'd like them, and if they make sense, you'll incorporate them onto the master branch. You'll merge them. Let's do that. So first, we just learned a new command that helps us figuring out what just happened. And I'd like to add it to our list of commands which are harmless, and you should practice them and you should type them as often as you can to understand what just happened in the reality of Git, in the world of Git. So that command is git branch. If you don't continue, if you just type git branch, it's a status checking commit. It will just tell us what branches exist and what branch we are on. If you continue that command, and we'll do it right now, it will actually make an action. So if we'd like to make a new branch, we'll type, again, git branch space, and give it a branch name. The branch name will be bark. So we dealt with dogs and meows. We'll make a new branch, call it bark. Git branch bark. Enter. Nothing. No feedback from Git. I'm lost. I don't know what just happened. Help me out here. What shall I type?
Oh, git branch.
Git branch, right? To know what just happened. So let's type git branch. Hey, wait. Can you explain that? There are two branches. One is called bark. Makes sense. We just made it. One is called master, but the one which is highlighted in green and the one which is highlighted by an asterisk is master. That means we are not on, if that makes sense, we're not on the new branch called bark. We are on master. We created a new branch, that's nice, and it's there, but we're not on it. What does it mean to be on a branch? It means that anything you do in the Git world, on the workflow, stage, and commit will be done on the branch you are on. So if I'll commit something, it will be committed onto master. If I'd like to commit it on my new branch, I'll have to somehow check it out, right? Let's do exactly that. Let's check out bark. Very easy. Git check out bark. Switch to branch bark. So some information out of Git, some response, but still, I'm a bit paranoid. I'd like to make sure, I'd like to find out what just happened. How do I do that? That's right. Git branch. Look at the difference. Previously, master was highlighted, now bark is highlighted. Great, I'm on that branch. I'd like to stop here and say, I cannot emphasize enough how many times personally I did that mistake when I created a new branch and thought I was on that branch, so anything I commit will be there, and started committing stuff and realizing I committed to the wrong branch. Probably happened a lot to many people. I cannot emphasize enough how much these commands matter and how often you should practice them and just type git branch. You're certain that you're on a certain branch? Great, type git branch. You'll be even more certain. If not, or if you're not on that branch, at least you'll know. So use these commands just as often as you can when you work with Git. Status, diff, log, and branch. So we just did git branch. We know we're on the right branch. Let's play around with it. Let's add a new file. Call it barkpy. Open it and add some content. So def, bark, dog, and not color, not name, what else? Weight. Whatever. So that function will get a dog object and its weight, and we'll ascribe that weight to the dog. So we'll do dog dot weight equals weight and return dog. Save it. Whatever. We aren't really executing Python. Alright, we have a new file. Also, I don't really like the file we made here, cat name. It's not just cats in our repositories, right? It's cats and dogs. Let's rename that file. So cat names, rename to animal names, cat and dogs name, whatever. So animal names. Right. So we have cats. Then we have dogs. And Rexing. names and our dog names. What I'd like to do now is make a new checkpoint to save that, to commit that. Before I commit, I need to add it. Let's make two different commits here. I want to do the git add period to just add everything. Let's split it up because first we added a bark, then we made some change to an existing file. I'd like to separate these commits just to have my code and my repository better organized. So let's do that. Git, so it's all in my workflow, right? I want to stage it. So what's the command for staging? Git add, correct? Git add bark.py. What just happened? What shall I type? Git status, that's right. Right? Hey, look, there's a new file, bark.py. One file got deleted, so renamed, right? So one file got deleted, cat name, and there's a new file which is totally untracked, animal.names. So the new file was already added or staged, right? We just did that. If we're going to commit, just the changes in that file will get committed. We just staged these. Let's do that. To commit, we type git commit -m and a meaningful commit message. So added bark.py. Great. Git status. That file, bark.py, is no longer in the status. It's clean. It got committed. It's in our history. Don't worry about it. Git will take care of it. Everything else is here in the status. I'd like to stage all of that together, so we can do git add period. Otherwise, do git add first file name and second file name, so the renaming will be staged together, not just as a deletion and addition. Git status, right? Let's commit that as well. Git commit -m, renamed cat name, or let's do cat name.txt to animal, or animal names.txt, whatever, right? So we added two new commits. Let's see the history. Let's visualize that. So git log. You see how often we get to practice these commands, which are extremely important to help us understand what's going on. So git log, here are our four commits. We added meow at first, then we added some function to that file, then we added a new file, then we renamed some file. And everything's here, and these commits actually contain the changes or represent the changes we did to our files, to the code. Perfect. Really nice. Let's do something very interesting, and let's see some Git magic. Are you ready? Some Git magic? So if you type git branch, it tells you you're on the bark branch, right? If you type git status, you see everything's clear, clean, all our changes were already staged and committed. Perfect. I can check out my master branch. What does my master branch contain? It has meowpy, and it has catname.txt rather than animal name, and it doesn't have bark.py. Remember how we said that the way Git thinks about files, so staging, committing, all of that stuff doesn't really affect the physical files in my folder. But if I branch to a different branch, if I branch off to a different branch that doesn't contain these files, what will happen to the files in my folder? Let's see. Git, to check out a different branch, we do git checkout. So git checkout, master. I would like to return to master. Hit enter and see what happens to the files here below. That's the magic. That's the power, right, of Git. So we have different branches, different versions of our repository. If things got committed, Git knows about them and relates them to a certain branch, like our cartoon here. So I had a certain branch that, sorry for being deleted, so that orange branch was bark, and here's master, and I added bark.py and animal names.text. If I check out master, I'll be at that point, and all my repository, which means the actual physical, as physical as it gets, files and folders will only be updated to the master version of my repository, or whatever branch version of your repository. You can check out a different branch, not only master, right? So you'll get new additions, deletions, files will shift around, and so on. Yes?
When you switch between branches that you're checking out, do you lose things in your workflow that were in the branch that you left?
So do I lose stuff? You mean if I just checked out master, what happened to bark.py? Did I lose it?
So suppose you hadn't committed everything.
All right.
Suppose you
Good question.
had things that weren't even staged.
Let's
that
do
were
that.
in your workflow.
I'll repeat the question. If I have stuff that isn't staged, wasn't added, and what happens if I shift branches? It will remain, but let's see. It's a very good question. You don't have to follow. I'll just make a new file. Example, even won't have an extension. Git status. There's a new file here. Ex doesn't even have an extension, and it's not staged or anything. Let's shift branches, or let's check out a new branch. Git check out bark. What do we expect to happen? We expect to see our bark.py. We expect that cat name will be renamed to animal names.txt, and that ex, which isn't being tracked, will remain. Let's do that. Right? We got our changes back. That's the magic. But things which aren't being tracked remain. It's a bit of a lie, because that file doesn't collide with anything else. If I were not to add a new file which has nothing to do with either branches, if I were to, on master, add bark.py, it's a different bark.py, it's a different branch, and then check out bark. So things might collide, and we'll talk about that really soon, how to solve conflicts. So if I will explain that again, you know what, I'll get to conflicts in several minutes, and we'll see how to solve that before we finish. Yes?
Just a quick comment. I think so. This is what happens if a file is untracked. Git just kind of is indifferent to it. But if you have a file that you've modified but you haven't staged it, Git will usually warn you before you try and check out a branch. It'll usually say you need to stash this or do something with it because this is on a file I'm tracking. I don't know what to do with your modifications. Either commit them or get rid of them. So it will kind of stop you from doing something like that.
And we'll see that soon. All right. I'm deleting ex. I'd like to check out master again. And what I'd like to do now is declare a situation in my code like we had with Max's aromatic branch and with Mark's isodesmic reaction branch. I'd like to have a finalized piece of code merged into the current state that I care about, which we just called the master branch. So I'd like to merge a branch onto master. Let's do that. In other words, I'm saying that I really agree with all the changes I did on the bark branch. I'd love to have them on my official version of the code. So let's do that. In order to merge a branch onto master, first I'd like to figure out what's going on. What just happened? Which branch am I on? Right, I just checked it out and it says so. I'm a bit paranoid. I'd like to really check out, really understand what just happened. So I'll type git branch without anything after it. It's just a status command, and it will tell me which branches I have and which one I'm on. I'd like to merge bark onto master, and let's do that. All right, changed my mind. We'll do that in a minute. Just before we merge, just to make things more interesting, we're on the master branch, right? Git log will give us only these two commits and not the commits we had on Bark. I'd like at this point to make a new branch. We will use it later, all right, for a different, to show something else. And then we'll continue with what we started. So let's all type git branch to make a new branch. If you give it a branch name, then the current state you are, master, will also be the current state of a new branch we're creating, and we'll use that later for a different example. So git branch bark2. If we type git branch with nothing after it, we'll see we have bark and bark2, and we have master. We said we'd like to merge bark onto master, like merging the aromatic feature in RMG onto RMG. In RMG, we'll do it online on GitHub, but it's a very similar concept. So here we'll type git merge bark. We're already on master, right? It's highlighted in green and with an asterisk, so we're merging it onto master. So we're merging bark to master, enter. Look, everything changed to the status of bark, and it tells us exactly which files changed and what got added or deleted. If we type git log, just a minute ago when typing git log on master, we saw our two commits that master consisted of. Now master also incorporates the bark branch, so typing git log will give us 4 commits. The 2 from bark got added here. Any questions?
You try to merge when you're on the Bark branch. What happens?
I don't know. If you try to merge when you're on the bark branch, what happens? Same thing, or?
Yeah, you can merge your master back into your branch to be able to.
If you're on Bark and you try to merge Bark, I think it might just
I think you need to be on the branch you're merging into, but I don't know, it's a good question.
You can merge master to branch.
I think it'll say, because it'll try and fast forward, and it'll fast forward to its own commit, so it'll just be like nothing happened. Yeah, nothing.
If you branch bark onto
Bark.
bark,
Yeah,
but
bark,
can you
bark,
can you merge bark onto master while you're on bark? I don't know. Yes, you
yes,
can.
because you
Yeah.
can say git merge, and then
Master.
the thing you're merging,
Yeah.
and then the base, or
All right,
handle,
all
or
right.
etc.
So you see, even experienced people don't really know exactly, and that's okay. That's perfect. That's great. We don't. The essence of today's session is to understand how Git thinks. All of these details are available online, and you'll see exactly the syntax and what to type. Let's do something very interesting now. I'd like with you to create a merge conflict. It's gonna be scary at first, but if you were to leave this session without seeing what a conflict is and how to resolve a conflict, then going to the real world and practicing Git and seeing a conflict, what do I do with it? And it's scary. So Git shouts at you, there's a conflict, and it's all red, and what do I do? It's fairly simple. So to create a conflict, what exactly do I want to do? I'm gonna change my mind again, just because I'm allowed to. So remember how we did that bark2 branch? All right, I want to do something else. Let's not go back to it. I want from this point to make 2 branches. Did I confuse you? Never mind. We have commands that will show us what just happened, what's the situation, so I can't really confuse you. If you type git branch, you can see you're on master. If you type git log, you can see exactly what master consists of. If you type git status, you can see there's nothing else to be modified here, so you know exactly what's going on. I want from this point to create 2 branches, just because I'm allowed to. Let's type together, and I'd like you to practice that, because we're going to create a merge conflict. I think it's important for everyone here to see and practice how to resolve a merge conflict. So let's do that. So let's branch off to git branch. Let's give it a name, zoo1, just whatever. I'm typing git branch. Am I on the zoo1 branch? No, I made a branch, and you can see it's right here, zoo1, but I'm still on master. Let's branch again from master. We are on master. We made zoo1, but we're not there. We're on master. So anything we commit will be on master. If we type git branch with a branch name, we'll branch off of master now again. Let's do git branch zoo2. Typing git branch again, right, to make sure we have 2 new branches. Let's check out zoo1. So everyone, let's do it together. Git check out zoo1. It tells us it checked it out. I don't trust it. I want to make sure. I type git branch. All right. It tells me here I'm on the zoo1 branch. So anything we commit now will be on the zoo1 branch. Perfect. Let's go to the files. Let's go to meow. And let's change it. So I don't like actually our print statement here because C doesn't start with a capital C and it doesn't tell me what it changed it to. So let's make a change. Change cat color to and curly parentheses color, and we just told it to print that actual parameter by giving it a format here. Whatever, we change that line. Alright, so make some change to that line. You can do exactly as I did here. So we changed line number 4, our print statement. I'll save it. Let's commit it on the zoo branch. So you already know how to do that, right? First, what just went on? Git what? Status. Alright, I have a modified file. In order to save that checkpoint, first I need to stage it. Right, so my command to stage is git add. I'm lazy, I'll just do git add period. What just happened? Git status. Oh, I understand what happened. That file got staged. Nothing moved physically. Just the way Git thinks about that file. Still not saved, still not a checkpoint. We haven't hit the ball. Let's commit it. Git commit -m modified print statement in meow whatever, right? But a meaningful commit message, I can't emphasize enough how important that is. Git log, I have here the latest commit that I see that we modified the print statement. I'd like to check out the master branch. I'm very satisfied with that excellent change to the code we all made. It's perfect, right? Test passed, it got reviewed. Let's check out master and let's merge zoo1 onto master. Git merge zoo1. Great, we just did. I'm a bit of a paranoid. I'd like to make sure that zoo1 got staged. What will be the best, or what will be the correct status commit to see that the current master branch really contains the content from zoo1? What shall I type? So to see the content from zoo1, contents in Git are divided into commits. So I'd like to see that these commits are present on master. Git log, correct. So git log on master. Wait. Git branch, just to make sure I'm on master. Yes, I'm on master. All right, so whatever we see here is actually on master. Git log. Look, modified print statement in meow. That's the most recent commit. We just did it. I'm hitting Q. I didn't say I'm hitting Q to go back to the terminal, to the command line and writing stuff. Beautiful. I'd like to check out zoo2. So we're in the game like Max and Mark, right? Two different branches from the same point. If I were to visualize it, we have master. From master we have zoo1 and zoo2. On zoo1 we change some line, the print statement in meow, line number 4. Great. zoo2 was at the same point. It's unaware of zoo1. Let's check it out. Git check out zoo2. Git branch, just to make sure what branch I'm on, to be just definite. Yes, I'm on zoo2. Let's make some changes to our files. my editor tells me, hey, something has changed here. That's right. I told Git to switch a branch, so the contents of files might change, and my editor warns me, so I'll tell it to reload. And here's the original version without our addition of the F, remember, and whatever. Then I have a terrific idea for our code. Instead of printing, let's log it. So we have a fancy logger in our software. So instead of print, I'd like to say logger.info, and that will be saved, also printed to the screen, but also saved automatically into our log file. Because we just added a logger to our software, let's use it here, and changed the cat color. Great. To a new one, even greater. Let's save that. So that's Zoo2. I hope.
And we have a meeting at 1, so.
No problem. I hope you all feel there is a problem here, right? Because we just changed line number 4, that we previously changed it to a different thing, and previously we already merged it onto master, and now we changed it again. I hope you all feel that we did something wrong here, or it's not wrong, but there's going to be a problem if we are to merge Zoo onto master. Let's see. Let's check out the master branch. Alright. I try to check out the master branch, but Git warns me you can't really move around because you made a change and your local changes will be overwritten, so wait and rethink what you're doing. I'm uncertain of what I'm doing, so I'd like to gain more certainty. Let's type git status to see what's going on. And I see that on my zoo2 branch, there's a modified file. And I really care about that change because I added my new logger. So let's stage and commit it. So to stage, we do git add period or git add file name. Then to commit, git commit -m added logger to meow. Git log to just make sure, yes, the latest commit is what we just added. Perfect. Now we can check out the master branch, and it just did. It checked it out. Let's verify that. Great. Now I'd like to merge the changes from Zoo2 onto master, only we all feel there is a problem because, and let's visualize it. Let's use that example. We had our print statement from line number 4 in meowpy. Then we had one branch that changed that line, right? And we added F and the actual color with curly brackets, right? I'm not typing the entire line. We added some change like that, and we already merged it. So we were here. So that's merged. Line number 4 was changed. Then we have a different branch, the orange branch, and we changed the same original line. We are unaware of these changes, and we added a logger, and we changed the text as well, and would like to add it here, but it doesn't belong. It won't stick to each other because you changed. Git will ask us, wait, if you are aware of that original line, someone already changed it, you made some change, which is the correct version? So Git is very smart, but at some points it's very stupid, and it begs for help. It will beg for some human help to tell it, so what is the correct version of your code? Which version would you like to save? Would you like to keep? Let's do that. Let's see what Git tells us. I'd like to merge Zoo2 onto master. So git merge Zoo2. And it tells me in all caps letters conflict merged conflict in meow.py, automatic merging failed, fix the conflicts, and then commit the results, and it screams at me that the auto merging failed. What do I do now? Let's see. Let's start with git status to see what's going on. It tells me you have unmerged paths, fix the conflict, then commit, and there's unmerged path, meow.py, something went wrong here. I want to really see the file. Let's see, and Git helps us and marks meow.py, the file that has a conflict, or several files that will have a conflict, and Git will add some annotations to mark the conflict. I'm reloading the file, and you see that these annotations were added by us. It tells us that the head, which means the latest commit on the master branch before we're trying to merge and add stuff onto it, the head had that line. So someone already changed it before I did. Then I made a different change. So on branch zoo2, between the equal signs and these signs, that's my change. And Git can't really decide because here it's not a technical thing of committing stuff. Here it comes to understanding or thinking what's best for my code. And only a human currently can do that. So I'll create one version, but before I fix it, the basic thing to understand, to fix a merge conflict for Git, all you need to do is delete these annotations. If you do, as far as Git is concerned, you just solved the conflict. But not for the code. I don't need a print and a logging statement. I just need one of them. So let's choose my version. I want to keep the logger, but I see the message that someone did here makes sense. So let's keep that message. I like it. So I'm copying that message. So you see, I'm doing what the human, the coder, the developer, the programmer should do, right? That's the version I'd like to keep. It's a combination of both. You don't have to. You can say, I want to keep one of the versions, the first or the second, whatever. Or make a combination like we did. As long as you remove the annotations, Git is happy. You need to make sure you are happy. As in, if both are happy, that's great. I'm saving that file. I'll go to the terminal, and I'll tell it, I'll add it, and then it's not can you help me here? It's not a rebase continue, it's a merge continue. How do I continue that? Dash continue? Alright. And I need to add first. So, alright. And let's again type git status. I say the same thing, there is a modified file, but now the modification don't include these weird annotations. So if I'll tell Git to continue merging, it will be happy because the annotations aren't there. So I'll need to first stage that file and tell it I do care about it. So git add meow. Thanks. Git add meow. Status again. I see it's green. And now I can tell Git to continue merging. So Git,
You don't continue.
no?
Git commit.
Git commit.
Git commit.
All right, in merging? All right, thanks. Git commit -n.
So if you just do git commit, it will actually pre-populate
The messages. Right. So if you do git commit,
It
and
will bring up the editor.
yes,
but
and we haven't
it will
seen-
say like
Right.
very explanatory.
let's do that. So I just type git commit without a -m, so I have an editor here. If you wondered how sometimes you have multi-line comments for a commit, you can do it through the editor. Here it tells me there's a merging going on and there are conflicts. Everything that's commented out will not be included in the commit message. You don't have to bother about deleting it. Everything which isn't will. So I'd like to say here, modified the print statement. Actually, we made it into a logger. Made it into a logger. keeping the original content, whatever you want. So here you can see a multi-line comment.
Well, I would say in general, if you're doing a merge on the command line, you should keep the merge.
The original message, the merging
That
Zoo2.
should be the title, merging something.
Alright.
You can add more details.
Merging Zoo2, thanks to the comment max. Modified print to logger. Alright, that's what we did here. I'll close the terminal, Control X, and yes, I want to save the changes. I just committed it. Let's do git status. Nothing, everything's clean, so everything was committed. Git log, and I can see the final commit was that I merged some branch onto master. I resolved the conflict. If I go to the actual file, I'll see the content. It's the updated content. No markings, no strange annotations. I have my logger and I have the version of the text that I'd like to keep, and everything got resolved. I'll sum up what we did today. I know we were supposed to terminate, to end the session at 1, and we're 2 minutes to 1. Technically, we did what we wanted to achieve. What I still haven't discussed is how to apply our knowledge when you work with GitHub, with the RNG environment. So after the brief summary, we can take a 5-minute break or 10-minute break, and then return, and I'll be happy to show that. But that was a complete introduction to Git. That was a complete session. I'll briefly summarize what we did. First, we said that Git is a version control tool. It helps us organize the workflow of programming, of writing code, of managing a repository. Git thinks of our files and folders as being unstaged in the workflow or staged, and you can do whatever you want here, stage parts of files, entire files, deletions, and then that entire chunk, you hit the ball and you commit it. Nothing really changes physically on your drive, on your files, when you do that, only the way Git thinks about your files. But when you change branches, then the files will actually change as well. If you change from one branch to another, or go back to master, or merge, and so on, then files will also change if they're different on different branches. We saw our important status commands to tell us what's going on. First, we have git status. Will just show us everything which isn't committed yet. If we have modifications which aren't staged, if we have modifications which are staged, we will see here. We can do git diff to see exactly what's different in the unstaged modification in the workflow, what's different than the staged and committed version of our code on a certain branch. We can do that for a specific file as well by giving the file name. We have git log for printing all the commits we have on a certain branch, and we have git branch to just show us which branches are available on our repository and which branch is currently checked out. As I said, I cannot emphasize enough how important it is to use all these 4 commands as often as possible. And I wish you all happy Gitting and happy coding. I hope it was helpful just for understanding how Git thinks. There are lots of other commands. You can look at the Git cheat sheet, you can look them up online. There are GUI softwares as well, Git Cola, Git Kraken. They're very helpful. Make yourself a favor, start working with the terminal. It's incredibly helpful to understand the language of Git and master it. Then if anything happens with the GUI, you'll have confident in yourself. You can go back to the terminal and fix it. We're always here to answer any questions you have in Git or otherwise. I'd like to thank you all for participating in the Git session. If you'd like to stay here after a 5 or 10 minute break, we'll see examples of how to actually change code using Git and speak with the GitHub cloud. Great, so thank you very much. Questions? Yes, please. Yes.
Just not a general question.
Yes.
Probably because I don't quite understand how Git works. Is so when we merge like one of the branches into the master
like the question is, what's the purpose of keeping a branch after it got merged, right? Yeah, excellent question. Not a lot. Maybe I can get some help answering that question. As far as I can see, nothing in particular. You can think of cases where you'd like to continue developing on that branch, but then you can say it's the same as branching off of the current master. So there's no particular use of that branch in the actual workflow when we work with the online repository on GitHub. The way we'll do it, we'll update our master branch to be an exact copy of the online repository of the official version. We'll branch off of that, giving the name of the feature we'd like to develop. We'll develop something, we'll push it. We won't merge locally, we'll push it to GitHub. There, tests will run. First, we can also run them locally. Tests will be run, someone will review it after we ask for a review. If everything's great, we'll merge it online, so nothing happened locally. Then locally, I need to remember to delete that branch because it doesn't make a lot of sense to keep it. It will just clog my branch list. And it's an excellent question. I don't find any use for a branch that already gotten merged onto master. I'll just go ahead and delete it. The way to delete a branch, and again, all the things I haven't mentioned, there's tons of things you can Google. So git branch -d and branch name. If you're not on that branch, it will get deleted. Sometimes it will warn you if a branch wasn't merged locally, but we're not working well locally, we're merging it online on GitHub, so you can't do the -d thing, so you'll do -D to force delete a branch, even though locally I haven't merged it onto master. Git just wants to protect us from deleting a branch that didn't get merged. But we're not merging it here, we're merging it on GitHub, so my local version of Git doesn't know about that. So practically I will do git branch -D space branch name to delete a branch that was already gotten merged on the official repository. Thanks for the question. We had another question? Yes.
So when I was on the master branch and when I make a new branch like zoo1 or zoo2, looks like it's just cloning the master branch.
Absolutely.
Right?
Yes. I'll repeat the question. When we were on the master branch and branched off and created two branches, zoo1 and zoo2, looks like it just cloned the master branch. Absolutely correct. And that's also why we did it together, to create a conflict on purpose, simulating, mimicking two different persons on two different computers, branching off from master at the same time. For our exercise, if we were to branch to zoo1, make the change to line 4, and merge it on master, then on the updated master, create zoo2, we wouldn't have a conflict because we were to start off from an updated version which doesn't conflict with anything.
So this is the default behavior when you make a new branch. It'll just because it doesn't know what else to do, it'll make it at your current wherever the other branch was based off of. But you can give it a second argument, I believe, that tells it which commit to like create that branch on. In which case, even though you're checking on master, you could have created a branch that was its head was another branch or something like that. But there's all sorts of ways to like.
Yeah, it's infinite. Yes.
Yeah.
There are lots of options. I wasn't aware of that particularly. Right. There are lots of things you can do. That's right. So the default behavior, as Mark commented, if you don't tell it anything else, is the current state, just to clone it, right? Yes. Any other questions? Thank you for surviving. Git isn't easy, but I think for you now, it's very easy. At least the basics. Anything else, ask, Google, and stay safe with Git, as we said. Great. Yeah, another question, please.
So Git I logged in, I signed in to my account, and I was
On GitHub, sorry?
on GitHub.
Online is GitHub, right?
All online is GitHub.
Online is the GitHub, right? I didn't explain that correctly. If you'd like, I can briefly comment on that, and then you can ask your question. Git is a software. It's not directly related, explicitly related to GitHub. Git is just the software for keeping track of your code, the version control tool. Then, where you store online your cloud could be GitHub, could be other, there's Lab Hub, right? GitLab, all right. So there are other cloud services for Git repositories. GitHub is often used, and we use GitHub all the time. So that's why I'm saying that by default. So GitHub is what we have online. That's the cloud, github.com, as we saw before. And Git is just the software that will make changes locally and will also push and pull. And when you installed RNG, you did git clone and gave it the path. So you used Git to communicate with the cloud on GitHub. And the question was?
I see. Oh, so yeah, I was expecting to see some changes in the online, but when I went to the website, I couldn't see anything because I didn't put it on the cloud.
Right, we didn't tell it. And that will be the next session. We'll see how to communicate between the local stuff we do and with GitHub.
So for now, because I only have the software, I cannot communicate or play with some people. But when I put all of this information simply up, and if I give access to other person, then we can just.
And then we can collaborate on the code, each one from their own computer. That's an excellent realization, right? You have your repository locally, you make a branch, you push it, someone else can look at it, can review the code online, or play around with it, check it out to their own repository on their own local machine, and play around with that branch, test it or whatever. You can also access the server and tell the server to log in or to check out a certain branch of a repository and run the software on the server, right? So they can all play together very nicely if you know the tools and how to make Git pull a certain branch or check out a certain branch from an online repository, or push once you're satisfied with your changes. All right, let's take a 10-minute break. If you'd like to come back, we can have an intimate session of Git and GitHub and how to practically push code to an online repository and work with that. Thanks.